Good morning, and welcome to the first of what I believe will be two videos on the second section of Chapter 1 in your textbook. All right, Chapter 1, of course, is entitled The Science of Psychology, and the second section is research methods used by psychologists. All right, so what this chapter is all about is exactly how to design a study. All right. In other words, you want to collect a certain amount of data. How are you going to collect it? What methods are you going to employ in order to carry out your research? All right. And what are the advantages and disadvantages of certain different designs? All right. There's a lot of different ways that you can go about conducting your research. However, certain certain methods will provide a better data set than others. All right. So the research methods that we're going to talk about today are listed here on your screens. All right. The first is a descriptive research method, and then this is basically just going out into the world and writing down what you see, recording what you see somehow. It's mostly an observational kind of thing, although there can be some interaction between the researcher and the subjects. But again, there's no manipulation of variables. There's no changing of one variable to see its effect on the other. You're simply observing what you see. All right. So if Jane Goodall goes off into the woods and watches the group of chimpanzees that she's studying, and she just writes down everything that they do, that is a descriptive type of research. Now, correlational studies are a little bit different. These are studies that where you look at the effect of changes in one variable and what those changes, excuse me, what those changes affect the other variable, or how those changes affect the other variable. However, again, it still generally doesn't have a manipulation involved with it. All right, correlational data might be looking at the relationship between income and the size of your home. Okay, it might look at the relationship between the height of a person and the weight of that person. All right, those are correlational studies, and again, there's no real manipulation occurred here. The last one on that list was experimental methods, and those are true research. You're actually manipulating the one of the variables to see its effect on the other variable. Now, let's go into each of those three in a little bit more detail. All right, descriptive research methods. These are research methods whose main purpose is to provide objective and detailed descriptions of behavior and mental processes. All right, at least in terms of psychology. But descriptive research methods can be used to make observations on anything. All right, it doesn't have to be just psychological details. Now, unfortunately, because you're simply going out and recording detailed descriptions, doesn't mean that you can even speculate about what's causing the things that you see. All right, you're just describing them. You're not really getting into the cause and effect relationships here. Now, in terms of descriptive research methods, there are three major types. You've got observational studies, which is literally just watching and writing down or recording somehow what you're actually seeing. There are also case studies, and these are when you actually take one and only one subject and you make observations about that individual. And then finally, there's survey research, where essentially you're taking a poll and asking people to record their opinions or their answers to a certain kind of question. Each of these three kinds of methods are limited in a great detail, well, in their a level of detail, because again, they're only making observations or describing things that they've seen. There's no actual manipulation of an experimental variable, and therefore you can't come up with a cause and effect relationship here. All right, now, over the course of the next couple of slides, we'll talk about each of these three descriptive research methods, all right? But all three of them fall under the main heading, descriptive research. So let's begin with observational techniques. In this case, the researcher directly observes the behavior of interest, all right? So the example that I gave you earlier of Jane Goodall sitting in the jungle, observing what the chimpanzees were doing, that is an observational technique. All right. Specifically, what she did was called a naturalistic observation. And this is a descriptive research method in which the behavior of interest is observed in its natural setting. Now, it doesn't just have to be wildlife in the jungle or in the fish pond or whatever it is. It could be, you go into a church and you observe the behavior of the congregation. You could go into a bar and observe the behavior of the patrons of that bar. All right. But the important thing about a naturalistic observation is that the researcher himself or herself does not get involved in the behavior that they're observing. All right. So you go into the bar, you sit in a booth, and you just watch the people around you. You don't participate or interact with those folks. All right. Jane Goodall, in a naturalistic observation, would not have interacted with the chimpanzees. If she could avoid it, she would keep them from knowing that she was there at all. Now, if Jane Goodall was to actually start to participate in the activity of the chimpanzees, then we would move from naturalistic observation to participant observation. And this is a descriptive research method in which the observer becomes part of the group being observed. Now, Jane Goodall cannot become a chimpanzee, so that's kind of a silly example. But if she was to interact with the chimps, then that would be participant observation. However, if a person observing the behavior of patrons in a bar was to go and go up to the bar and start drinking with the other patrons and interacting with them, then he or she would become a participant in this activity. All right, and so that's the difference between naturalistic observation and participant observation. All right, but again, both observational techniques, generally speaking, you're not trying to specifically manipulate a given variable in order to record the results on another variable. All right, you're just making observations. Now, a case study is a second kind of descriptive research method. In this case, the researcher studies an individual, one person or one animal or one whatever it is, but they do so in great detail over an extended period of time. Now, the point of this is to try to learn as much as possible about the individual that's being studied. You find out everything that there is to know about that individual. However, the difficulty with this is that results of these kinds of studies cannot be generalized to the entire population. All right. For example, if somebody is sick with COVID-19, then by the way, that cough is not COVID-19, that's pollen. But just because one person either needs a ventilator or doesn't, or has this result based on this medication, that doesn't mean that you can generalize this to the entire population. However, case studies can be important because they can lead to ideas that may lead to testable hypotheses that can eventually be studied in experimental research later on. All right. But in and of themselves, case studies are not really um, valuable in terms of generalizing a conclusion, because again, you're only basing your conclusions on the observations made on one individual. Moving a little further, and getting a little bit more accurate, is what we call survey research. Again, this is the third kind of descriptive research method. And here, the researcher uses questionnaires and interviews to collect information about the behaviors, beliefs, and attitudes of a particular group of people. And this, generally speaking, is a little bit more accurate than, for example, a case study, because you're actually going through and using multiple individuals as opposed to just one. The difficulties with survey research are several-fold. First, you have to assume that people are going to answer the questions honestly. In the last set of videos, I talked a little bit about the last presidential election, and how the polls were just so wrong. All right, and we talked about why those polls might be wrong. But one of the things that researchers have discovered about the polls taken in the 2016 election is that people who were going to vote for Donald Trump did not answer the polls honestly. All right, I don't know if they were embarrassed, ashamed, sad, whatever it was, but they did not tell the truth to the pollsters. Now, I don't know if this is true or not, but I've read articles that suggest that Trump voters didn't tell the pollsters that they were going to vote for Trump. They either said they were undecided, or they said that they were going to vote for Hillary Clinton. In addition, the questions must be asked in an unbiased manner. So, depending how you ask a question can be very important. All right. For example, there's an old movie line which has become sort of a joke over time, and it's a cop asking a husband. So Mr. Smith, when did you stop beating your wife? So how do you answer that question? All right, there's no accurate way to, if you, first of all, hopefully he didn't beat his wife, but if he did, he's not going to say last week, all right, because that implies that the week before that he was beating his wife. All right, there's no accurate way to answer that question. And so when you design a survey, you have to make sure that the questions that you ask are unbiased, all right, that they don't lead to the answer that either you want or don't want, or whatever your ideas are. And finally, a survey has to take a representative sample of the relevant population. All right, again, going back to the 2016 election, most of the polls were taken along the eastern seaboard, New York, New Jersey, Connecticut, and those states tend to have a very high concentration of Democratic voters. All right, and I think Hillary Clinton won all of those states. All right, but the pollsters didn't ask the people in the middle of the country, and therefore they had a unrepresentative sample of the relative population. Okay. So when you're doing a survey, there's a couple of things that you need to keep in mind. All right. First, a population is the entire group of people that a researcher is studying. So if you want to talk about the American electorate, all 350 million people in America, or if you want to talk about people of voting age, maybe, I don't know what it is, maybe 200 million. I'm not absolutely certain. Probably less. Probably around 200 million. I don't know. Anyway, it would be almost impossible to survey every single person in America, although the United States Census does a pretty good job of it every 10 years or so. So what you really do is you go out and you choose a subset of that population, and we call that subset a sample. All right. The sample is defined as a subset of a population that actually participates in a research study. These are the people that you actually ask the questions of. You don't ask the entire population because that would be prohibitive, but you ask 1,000 people or 2,000 people, whatever it happens to be. But in addition, you need to make sure that you randomly sample that population. All right, the sample that you choose has to be representative of the actual population. Again, if you just survey Democrats about who's going to win the presidential election, you're probably going to get an answer that points to the Democrat. If you choose a representative sample, then you get a more accurate representation of what might actually happen. So random sampling is a sampling technique that obtains a representative sample of a population by ensuring that each individual in a population has an equal opportunity to be in the sample. If you don't poll anybody in Texas or Arkansas or Utah or Montana, all right, and everybody you sample is in New York and New Jersey, then your poll is probably not going to be accurate. All right, you have to get a random sample that matches, that looks like the population that you're trying to generalize this opinion or behavior to. Okay, so that's survey research. Okay, now for the next step, let's talk about correlational studies. All right, this is the second of the three major types of studies. And a correlation is simply a relationship that exists between two variables. And so a correlational study is a research study in which two variables are measured to determine in which way they are related. All right, in other words, how well either one predicts the other one. All right, in other words, if if you have a large income, you are more likely to own more appliances in your house, more TVs, more refrigerators, microwaves, stereos, you name it, whatever it happens to be. All right. If you have a lower income, you're going to have fewer of those kinds of things. And so a correlational research study looks at how income predicts the number of TVs that you have in your house. All right. And a variable is any factor that can take on more than one value. So income, obviously, you can make $10 a week, you can make $100 a week, you can make $1,000 a week, or more, right? And the number of TVs in the house is can be one or two or three or four or five, whatever it happens to be. Honestly, nobody should have more than one TV in their house, but that's an opinion, not anything else. I'm not even convinced that anybody should have any TVs in their house, but that's a whole different story. So what the correlational study does is it looks to see if there's a relationship between income and the number of TVs, for example. Okay, it might look at the relationship between height and weight in people. It might look at the correlation between the amount of food available for a certain species of bird and the number of baby birds that survive that spring. Those are correlational studies. Okay. Now, mathematically, the correlation coefficient is derived using the formula that's shown here. Now, before you get all hot and nervous and sweaty, all right, I'm never going to make you calculate this. All right, but I do want to point out that there are two variables here, the x variable and the y variable. All right. All right, this is each individual value of x from I equals 1 to I equals to n, whatever n is. That's the number of individuals in this population or in this sample. All right. This with the x with the little line over it means the average value. All right, this is each individual y minus the average value of y divided by this mess. All right. Now, it turns out that based on the way that this formula is set up, that the correlation coefficient ranges between 1 and -1. Okay. And so this is an important aspect. Now, you don't need to know this formula, all right? And I'm never going to make you calculate it, but I want you to see that we don't just pull correlation coefficients out of our behinds, all right? They actually are calculated somehow. So what exactly is the correlation coefficient? Well, based on the formula on the previous slide, we know that the correlation coefficient ranges between -1 and +1. Okay, so the highest value of correlation can be -1 or +1. The sign indicates whether the correlation is positive or negative. And all that means is if the relationship looks like this, where as x increases, y increases, this is a positive relationship. And if the relationship looks like this, where as x increases, y decreases, this is a negative relationship, all right, a negative correlation, okay? So this is positive correlation. This is a negative correlation. Now, either way, whether it's -1 or +1, that means that the two variables are perfectly correlated, meaning that if you know the value of x, you can exactly predict the value of y, and vice versa. And notice the term here that says absolute value, all right? So a correlation coefficient of -1 is a very strong coefficient that's just as strong as a correlation coefficient of +1. All right. 0 is the weakest correlation. That means that there's no correlation at all. There's no relationship between x and y. All right. Now, we can always calculate the correlation coefficients, but sometimes it's easiest to actually look at a picture of the data to determine the strength of the correlation that we're talking about. And so these are graphs which are called scatter plots, all right? And essentially what they are is just visual representations of correlational data, okay? Now, if you go through these, first, each point, so each yellow point here and here and here and here and here and so on, represents the scores for two variables, the x and the y, right? So it makes a data point on this graph, all right? And each participant in a study is given a data point. So if you have 3 participants, you've got 3 data points. If you have 1,000 participants, then you have 1,000 data points. Now, the 2 graphs on the top of this page are both indicating a negative correlation coefficient. In both of these cases, notice that the slope of the line is negative, right? As the value of x increases, the value of y decreases. The difference between these 2 graphs is that the one on the left has all 3 data points exactly on the same line. There's a linear relationship here. That represents a perfect correlation, all right? And notice the correlation coefficient is -1. In the second graph, although we still have a negative slope, the data are a little bit further apart. They're spread out a little bit. And so what that means is that even though the correlation is still negative, as x goes up, y goes down, the correlation coefficient is somewhere between -1 and +1. On the next 2 graphs, on the bottom row there, the first 2 there both show positive correlations. And you can see that in both of them, as x increases, the value of y increases as well. However, in the first one, the data are kind of spread out a little bit, meaning that the correlation coefficient is somewhere between 0 and +1. In the middle one, all 5 of the data points there are linear. They're lined up right in a row, and therefore that is a perfect correlation, meaning a correlation coefficient of +1. The final graph on this page shows you a bunch of data that just spread out all over the place, like somebody took a big pot of spaghetti and threw it on the wall and see where it stuck. All right. In this case, there's no correlation at all. There's no relationship here between the value of X and the value of Y. Okay. So that's where I'm going to call it a day for this video. This is, again, the first of 2 videos on research methods. So please stay tuned for video number 2. And I hope you learned something.